Hey guys, it's Sam here from Core Electronics, and today we're going to be taking a look at how we can get this data that's on our particle board, be it a photon or an electron, onto a display. We want to be able to visualize what's going on, on the insides. Today we're going to be taking a look at using character displays. You've also got graphical displays, but today it's just going to be looking at the character ones. So we've got 16 by 2 character displays. So as you can guess, displaying characters in a bit of a grid format. So rather than controlling each pixel, there's set spaces for where your characters can go. Now it uses the standard ASC2 characters, the character library. And it's 16 by 2 means there's 16 spaces in a line and 2 lines. Now you can also get 20 by 2, 20 by 4. They're kind of the main sizes for character displays. There's a few other more niche ones. But yeah, that's what we'll be taking a look at. If you're after graphic displays, check out our other tutorial on that. They actually go through and render the display pixel by pixel, so working a bit differently there. But yeah, with our displays, there's 2 main technologies. You've got LCD and OLED. Now, with OLED, it's organic light emitting diode, in case you're wondering, and you've actually got this sort of material across the screen, which is actually emitting light. So pixel by pixel, you're emitting that light, which gives you really crisp kind of contrast against the dark background. You can get a bunch of different colors. We're working with monochrome displays, so just single color, not multicolor. It's a little bit more complex. Whereas with the LCD, there's a backlight which is sort of emitting this this LED light, and then you've got what's called a liquid crystal matrix over the top, which sort of distorts and refracts the light in different ways to give you the pixels. And that's great. It's been the traditional sort of flat screen technology for quite a number of years now, but it does have the disadvantage, compared to the OLED, of that really crisp contrast and great low light viewing conditions. So yeah, we'll take a look at how we can get set up. Now we're going to actually go through using both the LCD and the OLED varieties. So don't worry if you have one or the other. We'll go through the circuit setups, the code, and the code's actually really quite similar. The libraries are doing most of the heavy lifting. We're pretty much using them in, with the exact same line-for-line code. So we'll take a look. Now you'll need a particle board, be it a photon or an electron. We're using a photon, just a little bit simpler. And let's take a look at how we can set up our LCD circuit. So the red one is our LCD and the green one is our OLED, just in case you're wondering. Now, with our particle boards, they are 3.3 volt boards. They've got a 5 volt display which we can tap onto, but the input and output pins are only going to be outputting 3.3 volts, and the input pins should really only be handling 3.3 volts, or you can risk damaging your board. This LCD is a 5 volt LCD, which means we're going to be powering the backlight off the 5 volts to get a much brighter backlight. And we're actually going to be using a bit of a trick where we can wire up the logic to 5 volts. So obviously working between 0 and 5 volt logic. And we're still going to be using our standard 3.3 volt output, but it actually sits just above the sort of the threshold for whether the pin detects a high or a low bit. So it's not ideal, but it saves us having to get a logic level converter out. This way works perfectly fine, and you don't quite get as much brightness when you're running the screen on the 3.3 volts. So not entirely, the best way to go for it, but definitely the simplest way to get set up, and it's going to work. You're not going to damage anything by giving it 3.3 volts instead of 5. But you definitely don't want to be putting 5 volts into 3.3 volt devices. So we'll go ahead. I'm going to wire this up. And we can go from there. So something to note is that with these larger breadboards, you can see there's a bit of a space along here. You can see that. So that's actually not always connected on a lot of breadboards. In fact, for most it isn't, and you can get your cord out. You'll just be looking for this error in your circuit, not realizing that these 2 sides of your power rails aren't connected along there. So I like to just get some little white jumpers and put those in there, and it just guarantees that our power rails are going to be distributed across the board. So we'll go ahead and wire up these jumpers. Great. And now I'm going to break out the ground and 3.3 volt pins on this side. So this far power rail is going to be my 3.3 volts. for all the particle gear, I pretty much use this same breadboard layout because it gives you both 5 volt and 3.3 volt rails. Alright, let's get that in. Now we're actually tapping onto the V in pin, which is directly connected to the USB 5 volts. So that's how we can, power it off an external pin. But when we're powering it over USB, it does let us tap into that 5 volt line. All right, I'm just going to spin this around because my power supply's over this side. Actually, I'll do that in a minute. First of all, we'll put the screen in. So we're going to be using the LCD display. Put it here, so we've got a nice amount of room for our contrast potentiometer. I'm going to place this in now, giving a bit of room on each pin. Now, the first thing we're going to want to do is wire up our backlight. We'll do this before we plug it in and turn it on. So our ground pin is on the outside, and our backlight is the far side here. Now, as I mentioned, we're going to be wiring this up to the 5 volts because it'll give us a much brighter backlight in the screen. Whilst, the backlight is going to work on 3.3 volts, it's really designed for 5 volts. All right, great. Now, I want to hook our logic up, but before I do, I'll spin this around so we can actually plug it in and see that backlight turning on. Now, always just double check your connections when you're working with power before you plug anything in. So, plug this in here, yep. So you can see that backlight is lighting up, and we can, if you change the angle of your display, you can see that backlight shining through. So that's another disadvantage of the LCD displays, is you can get, colors inverting or the frame inverting depending on your viewing angle, whereas the OLED is going to be a lot more consistent over different angles. But it really just depends what you prefer to use. All right, so now we're going to wire up our logic. So this is, telling our display what logic levels we're going to run, and we are using a bit of a cheat by sort of just using the 5 volt to get that brighter display, but then only sitting at 3.3 volt signals. It's up to you. You can use that logic level converter if you like, and it's probably the better way to do it if you're getting a more sort of permanent projector setup going. All right, so that's actually going onto our ground. And I'll get this guy. So positives on the inside there. All right, now the last thing we need to do to get the power section wired up is get our contrast pot wired up. So that's this little guy here, you can see, and it's controlling the contrast of the screen. So how brightly the letters are going to stand out against the backlit segments. So we want to take the middle pin of this over to our contrast pin, which I can see is right next to these pins. So I'm actually sort of working in reverse to the diagram, but if you flip it upside down, you'll be able to see. And then I'm just wiring up one outside pin to ground and the other to 5 volts. Now it doesn't really matter which one's which, it's just going to change the effect depending on which way you turn the potentiometer. So it really doesn't matter for this. Actually connect that to 5 volts, and the black one just to try and be a little bit color coordinated to our ground. Alrighty, now if we turn this contrast pot when it's, there we go. So we can see that there are our squares that our characters are going to be displayed on. There we go. So I turn it down and we start losing some contrast until it goes all the way back up. Now it won't have a really extreme effect until we actually start seeing some characters, so it's designed to be viewed from that angle there. But alright, for now I'll just turn that down, and we're going to wire up the data pins now. So we've got 4 data pins on this end. So we're going to go and wire those up. Now the pin closest to our backlight pins here is going to be connected to D0 on our photon. And again, you can use the electron for this. It's the code's going to work. The breadboard diagram is going to work. The electron's just a little bit bigger board, so as long as you connect it up to the same pins, the D0 to D5, then it's going to work exactly the same. So I'll connect these 4 up. And I'm just working right to left in ascending order on the photon. Alright, so there are our 4 data pins, and then we've got some read, write, and enable pins here that we're going to wire up. So on the other side, next to our contrast pin, we've got a wire which goes to D5. So we're using 6 pins all up on the photon. Next, we've got, I believe this is the enable pin, which in an LCD setup goes to ground. Don't need to connect that up. And the last one goes into D4 here. Alright, there we go. Now you'll know that you've wired this up correctly if you've got a space of, if you can see that there, there should be a space of 4 pins in between sort of this side and this side. They're extra data pins. You can actually connect these displays up using 8 pins instead of 4. I'm not 100% sure on the benefits of it. I think it might give you a bit of extra read-write speed, but it's almost instantaneous as it is anyway, so we're not going to worry about that. Now, because there's no code on this, it's just going to be displaying some random gibberish, so you can't really see anything on the display. That's because our contrast is too far down, so if we turn it up a bit, we can see the lovely random gibberish displayed quite clearly, and if we keep turning it up, it eventually kind of whites out the character segments versus the characters themselves. So that's probably, I'd say, a pretty sweet spot just there. Now, let's turn this random gibberish into something more meaningful using some code. So we'll scroll down to the LCD code. Alright, so I'm just going to copy this for starters and open up the Particle IDE. If you've never used the IDE before, go check out some of our other tutorials which cover, using the IDE, setting up your photon, that kind of thing. So we'll go build.particle.io. So the build subdomain of particle.io is our IDE, where we can access libraries, code everything. All right, so I'm going to create a new app. Need to go through and clean up my apps at the moment, and let's name this app LCD Demo. Cool. All right, so if you're familiar with Arduino, you'll see the void setup and void loop sections here. Now I'm gonna copy this code in. Now you'll notice we've got the hash include liquid crystal library. That's because we're going to be using the liquid crystal library that's been ported over from the Arduino libraries. It makes working with these displays super easy. All the functions can just be accessed, using lcd.print, print your data, lcd.clear, lcd.setCursor, everything else. So it makes it incredibly simple. This whole code takes up 14 lines. So we've got that in, but we actually need to, when we're working with the Particle IDE, go through and include the library in our menu tab as well. It's not just enough to write that in the code. So we're going to search in the libraries for liquid crystal. Now we want to be using that one. You can see the number of views next to the library, which kind of tells you how many people are using it, how popular it is. So the ones with the higher views are likely to be, really solid, work really reliably. So now we want to click include in app, find our app that we want to include in, LCD Demo, add to this app. All right, there we go. Now it's removed the previous code that we copied in, so we probably didn't need to do that, but I'm now just going to replace that. The line's exactly the same. That's all right. Now we want to make sure our correct device is selected. So I'm going to be using Photon Guy. I like to name my particle boards with the type of board they are, and then a fantastic, unique Australian name. Your naming convention is up to you. All right, now we're going to hit flush, and this will check. It'll compile it first, check for compilation errors. There shouldn't be any, and then it's going to upload it to our board over the air. So we'll wait for that to run through a compilation check. Yeah, flash successful. You can see on the board it's updating our new code. And we'll turn the contrast up a bit, and we can see our program running. So this is just a simple kind of Hello World type program, although it doesn't actually print Hello World, but it just tells us the time since the last reset on the board using the millis function. dead easy. We hit reset and that time is obviously going to clear because it's a different time since the last reset. So there we go, underway. And that's really all there is to using these character displays. This is the LCD one, so now we're going to take a look at using the OLED one. The code's almost identical, just using a different library to account for the different sort of data structure that needs to be sent to it, and the wiring is almost identical as well. We've just got to change a few of our jumpers here. So we'll go in and get stuck in with that. So I'm just going to unplug first, always best practice, and swap our LCD display out for our, see that, for our OLED. Alright, now we don't need the backlight wiring. I have included it in the wiring diagram in the article just to make it sort of as easy as possible to switch between the two. It's not going to harm it at all. It's also not really necessary, so keep it in, leave it out. Doesn't really matter. Now you notice we don't need the contrast pot. This is because we don't use a backlight. We don't need to adjust that contrast because the OLED material in this is emitting its own light. So we can get rid of these 3 wires. They're our power and contrast for there. And now we're actually going to be using 3.3 volts for the OLED. Because we don't have the backlight to worry about, we can just use it on 3.3 volt logic, and it's going to work exactly as intended. So I'm going to jump these back over to there. You can see that very well. And then you notice, so if we look through, we're missing the contrast wire because it's not necessary, and the only difference we're making is this pin here, rather than going to ground, it's actually going to go to our board. So we'll just for completeness sake, I'm going to unplug these, leaving our data pins exactly as they are, and I'm just going to go through and rewire these. So starting from our right hand side, this yellow wire goes into D4, then our white wire, which was plugged into ground, it's brown in the illustration, it's going into D5, and this blue wire is going into D6. So we're using one extra pin on our photon to do this, but that's not too bad. Alright, so we can get rid of those jumper wires, get rid of the contrast pot, and if you have a look, I'll just jump back to the build section for a little bit. This line of code here is actually the pin out for the liquid crystal display. You can use any pins you like. It's going to work identically, and you'll see in a minute with our OLED code. If you follow the pin out there, it's going to work with the wiring diagram. Feel free to use different pins if you like, but you're just going to need to go in and change each of the pins corresponding there. Now let's turn this on and start working with it. So wait for a particle to boot up, and we're going to go back down to our code and look at our OLED code. So again, we're going to copy all of that. Now before we paste it into the IDE, I'm going to go into our code tab, and we're actually just going to get rid of the liquid crystal display library. If we upload it to our board now, it's not going to work because the liquid crystal library is different to the OLED library. It actually does work at a bit of a pinch, but the OLED requires a bit more sort of timing specific commands, so you may run into issues using it for more complex kind of things. Alright, so I'm going to remove the liquid crystal library because it's just going to take up unnecessary room in our code. So that'll go in a second. It's been removed from our app. I'm going to remove that line as well. And I'm going to search for OLED. Oh no, sorry, that's searching for apps. I'm going to go into our libraries tab and search for OLED. Alright, now I want the Adafruit character library because it is an Adafruit display that we're using here. Alright, include in app. I'm going to include it in our LCD demo. Technically we're not using an LCD. In fact, let's just go in and create a new app. I think that's going to be a cleaner approach. So we'll go create a new app just so we don't get any code mixed up. So OLED demo, just for uniqueness sake. create this. All right, now let's go into libraries, include the Adafruit character library, include in app, OLED demo, add to this app. Fantastic, so now it's included that library for us. So we can go ahead and copy the code in from the tutorial. So pretty much the code's identical apart from the library inclusion, and you can see our setup is just a little bit different. So we're using the extra pin and the slightly different naming convention for the OLED display, but it's still using the lcd.begin commands to make it as easy to get set up and not have to change your code all that much. So going to, yep, so we've still got photon guy there. Let's flash this code over to our board. So again, we're just going through this compilation process. Fantastic, I can see that it's flash is successful. My photon is rebooting with the new code. And there we go. Again, a hello world kind of program, time since reset. It's nothing original, nothing unique, used by almost everyone who gets started with a character display, but it's an effective way to show some of the different functions. Now there's a lot more functionality in these libraries than we're using here. So we're just using the print and set cursor kind of commands along with the begin structure, but there's a lot more you can do with it, including scrolling, auto scroll, set your cursor to different positions, things like that. You can flash the display, turn it off, turn it back on again without losing the data that you've written to it. But yeah, go into the library in there and check out some of those different commands if you're looking to go a bit further. But that is character displays with Particle. Awesome source. We can write data to our screen. We can display variables. We can display strings like we are now. Do all kinds of things and visualize what's going on in the tiny brain of our microcontroller. So have fun with that, guys. Create some awesome projects, and I'll see you next time.